In this video, we'll be reviewing an important theorem related to triangles called the Exterior Angle Theorem. And the theorem states the measure of the exterior angle of a triangle is equal to the sum of the two remote interior angles. So there's a couple of big words in there. The word exterior angle means it's an angle that's outside of the triangle, is equal to the sum is, of course, having to do with adding things together. The two remote interior angles, remote means not the one that's closest, but the two that are farthest away. So we're given an example here. And in this example, we see that there's a triangle ABC. And the measure of angle A is given as 95 degrees. Angle B is given as 2x. And this little angle here is not given. But what I see is that there is what's called an exterior angle here. Now, I could solve this problem just by believing this exterior angle theorem and applying it, but I think what I'd rather do is use what I know about triangle sum theorem, apply it, write an equation and solve it, and then figure out what is the measure of angle ABC. All right, so here's what I know. These two angles, which I highlighted in blue, one is obtuse, the other is acute. They add together to equal 180 degrees because they're forming what's called a linear pair. This is also an exterior angle, but right now, ignoring that fact, this is a linear pair. So I can subtract, and I can get the measure of angle ACB is 35 degrees. Okay, so if the measure of angle ACB is 35 degrees, how does that help me find the measure of this missing angle, which we're calling 2x? Because I know from my triangle sum theorem that I can write an equation that the sum of the three angles of any triangle equals 180 degrees. And so I can add these two together because these are called like terms. I can subtract 130 from both sides. I can divide both sides by, this is 50 over here, I should make that clearer. I can divide both sides by 2. I get that x is 25 degrees. But the question didn't ask me for x. It says, what's the measure of angle ABC? So if this is 2x, that's double 25. So my claim is that the measure of angle ABC is 50 degrees. All right, now let's go back and let's see, could I have just directly applied this exterior angle theorem? It says the measure, and I'm going to apply this in red here. It says the measure of an exterior angle. Okay, so my 145 is equal to the sum, so I'm adding two things together, of two remote interior angles. So I'm going to add 2x and 95. Notice I'm calling these the remote interior angles because they're not the ones that are next to this. So I'm going to solve this equation by subtracting 95 from both sides. So I'll grab a calculator and I'll do 145 minus 95, and I get 50. So I'm going to say that 50, finish off my equation here, is equal to 2x. And so the 2x is the 50. I mean, I could go ahead and divide, get x equals 25, and then go back and plug the 25 back in. But either way, you can see I'm coming up with the same answer of 50 degrees. So I'm believing that the exterior angle theorem is something that I can use. Now, maybe after doing a couple more in that way, I would then begin to apply it. But I'm going to say to you, do you trust this exterior angle theorem enough to apply it right here? If so, we want you to find the measure of angle F. And so the measure of angle F is right here. You're going to put this video on pause, and then you're going to come back, and we're going to look together to see how we both approached it. Go ahead and solve that problem and find the measure of angle F. Okay, so to apply the exterior angle theorem, it says that the measure of an exterior angle, in this case 58 degrees, is equal to the sum, right, adding, of two remote interior angles. So I'm going to add x plus x. So I get that 58 is equal to 2x. I'm going to divide both sides by 2. And I believe 58 divided by 2 is 29 degrees. Therefore, x is 29 degrees, so the measure of angle F is also 29 degrees by applying the exterior angle theorem.